Hello, hello. I don't have to stand behind this thing, I don't think, do I? So I'm going to fix the intro just a little bit. So Scout Labs was my company, founder CEO. It was acquired last summer by Lithium Technologies, and so. And we were, and still are, at Lithium, is still in the business of analyzing and mining social media in real time for companies and for brands. So that product is still available. Go to Lithium Technologies for that. I'm not going to really be talking about Scout Labs specifically, but the process by which we went and actually analyzed text-based content is what I want to talk about today. I guess there's a lot of excited conversations and debates over whether computers can do sentiment detection and things like that. So I will give you my take on it after working on this for 5 years. I'm not an engineer. I'm the kind of marketing-focused person, and my triple PhD computational linguist probably could give a totally different version of this. But I'm going to kind of talk to you about it from the high-level perspective of what natural language processing is, what it can do now, and kind of what the trends are and what you should be looking for if you are a consumer of or using natural language processing or text-based analytics to make you ask smarter questions of your vendors, because nobody ever asked us hard questions. They're just like, do you have Twitter? So let's talk about NLP in general. So natural language processing is really that interplay between computers and humans. This could be speech to text, right? Humans give unstructured text out into the world, and a computer takes that and turns it into letters, which we can then process and do something else with. It could be machine translation from one language to another, those sorts of things. I'm going to really focus mostly on text analytics, which is the world of social media, and all of the huge amount of volumes of text that are being created are hugely unstructured. Very few actually have, use punctuation or sentences or grammar. I mean, it's very unstructured, but it's still useful nonetheless, and that's really what I'm going to focus on here. And the reason why this is super important is that we could take that giant, kind of fire hose of feedback that's out there and turn it into the world's biggest focus group. If you have a question, social media could become the mind of the market, and you could poll it on any topic, anything that you want to. And I think that was one of the most fun things at Scout Labs, is just to see what people are searching on. Of course, everyone usually starts with like, well, what are they saying about me? And what is Coke saying? What are people saying about Coke? And what are they saying about Pepsi? And are they saying better things or worse things? But then you start to get creative, like, wait, I could really ask them kind of anything. And we'd see Jamba Juice doing searches for styrofoam. We're like, why are they searching on styrofoam? Because they had styrofoam cups at the time, and people hated the fact that they had styrofoam cups. We see Coke doing searches for global obesity, and not just are people saying things about Coke or Pepsi. What's going on with the global obesity epidemic, and what share of the blame are we getting for global obesity versus Pepsi? That's really cool stuff, and that's when it clicks and you realize that, wow, this stuff could really be used for kind of anything. So that's really what we're talking about here. So before I can talk about the future of natural language processing, we got to talk about kind of where it came from and where it started. 25 years ago, natural language processing was really about rules. What we humans did, our input and our contribution to the whole thing, was to sit down and write rules. So if we wanted to create a spam filter, we would say, well, I'm pretty sure that spam is something that if it says a word in multiple times, that's probably going to be spam. So if it says Obama, 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 I'm going to label that as spam, and you ask the computer to go execute your rules. Go find every example of a word being used more than 5 times and axe it out of the system. That is a very simplistic way to do it, and that is not the way that we do it anymore. Humans' contribution to natural language processing now is to label data sets. So our job is to take samples and to label things and say, this one's spam, not spam, 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 not spam, not spam. The other side of the equation is to identify features which could be or could not be correlated to those labels. Our job is not to know. That is where the computers come in, and they will tell us now at this point which things are most correlated with spam or not spam. And it's usually very surprising. It's not always what you would have guessed, and that is why the industry has evolved the way that it has, and it's a good thing. So the problem with all of this, though, is computers have no chance in hell at doing a good job at natural language processing if humans can't do it at a pretty accurate rate. So take porn. That is one of the things that we absolutely have to be filtering for. When Mattel runs a search on Barbie dolls, they want to see one thing and not another thing. So porn, I would say, is probably one of those that can be labeled pretty clearly and pretty accurately, and that is someone's job, is to label porn. I wish you had that job. But to go through and say porn, not porn, porn, not porn, porn, not porn, that is our job. And I would say that this one, even though my definition and your definition might be slightly different, in general, this is one that can be labeled pretty clearly. I'm the first to admit sentiment is messy. I absolutely am one of the people that does sentiment scoring of text as it comes in and labeling of data, and you get really hard stuff. You know, what do you do with, dude, my Nikes are the Tom Jones of shoes? Is that positive, negative, or neutral? Because you got to label it something. So the interesting thing that we found, we do tons and tons of data analysis. I should be using past tense, but I have to work that out of me. But the reality is that 3 college-educated humans only agree with each other on sentiment scoring 83% of the time. So I would say that's positive, and you would say that's positive, and you would say that's positive 83% of the time. The rest of the time we're disagreeing, and we're not sure exactly how to classify that. Now, those accuracy rates get obviously much higher if you're not dealing in social media. Social media is the least grammar accurate. It has, the most misspellings. It has all the, lack of contents, short things. If we were doing sentiment detection on press releases or newspaper articles, it would get much higher than that. But I'm kind of talking and going to frame this in world of social media. So when our algorithms can get accuracy rates that are in the high 80s, actually the humans agree with each other 86% of the time, and our algorithms are agreeing with humans 83% of the time. So our algorithms are agreeing with humans a little bit less than humans agree with each other. And those are the kinds of questions that you should be asking your vendors about kind of what are the baselines and what are we talking about here when you say that you're doing automated sentiment detection. It's super hard to do. But it's really, really worth doing because all of us know the huge amounts of data volumes that exist out there. It's only increasing. And if you are a company, if you are Netflix, if you are Disney, if you are these things, nobody has enough staff to go and read every single one of these. And to have a giant negative spike hit on your radar in a very real time, a lot of these sentiment scores we could do, there would be only less than 10-second lag between the time someone posted it on Twitter in China and when it gets scored in the system is less than 10 seconds. That's an amazingly powerful tool if you can do it and do it well. So it is a quest worth doing, I would argue. But we can get much better accuracy rates. And so I want to talk a little bit, just three quick trends because they're making me stop talking in 50 seconds. So, although I asked for a few extra minutes and you said yes. So I'm just going to make sure that I get through at least my 3 points, the future of NLP, which is what I was supposed to be talking about here. So a couple of things. One, harnessing the wisdom of the crowd. As we said, accuracy comes from labeled data. So if we can get more labeled data, if we can get more accurate labeled data, we are going to get higher accuracy rates. And so 2 things are really essential to build this into a software application. One is learning algorithms that actually improve with, take in new data, and recalculate dictionaries and classifications on the fly. That is essential step number 1. Essential step number 2 to truly harness the wisdom wisdom of the crowd is to embed those learning algorithms into a collaborative system. So Scout Labs, by design, was not designed for a single user, researcher, nerd within a company who wanted to go and play with data. There are hundreds of people at Coke, hundreds of people at Netflix, hundreds of people at Citibank using Scout Labs as the platform by which they all track and monitor. That is a huge benefit to us because I now have hundreds of people, tens of thousands of users who are seeing something, and if in the system it doesn't look quite negative, it really looks a little bit more positive, they change a score within the system. All of that is more labeled data that we can actually, if you have learning algorithms, can actually use to improve the accuracy rates over time. Incredibly powerful. The other piece really, and everyone talks about sentiment. Sentiment is incredibly powerful. There's so much volume out there to be able to sort things into red, green, and gray is absolutely valuable. You can trend it, you can track it, all of those sorts of things. But why stop there? There is no reason why the technology can't be used to do much more nuanced identification of emotions, intentions, all of those sorts of things. Why not use the same technology to find people at moments of indecision? I'm thinking about buying a new car. Who do you guys think? That right there is a language and a linguistic key to that sentence, which actually you could unlock a huge amount of opportunity. So things like wishes. If you are a product manager, to be able to pull up in real time exactly what people are wishing for is incredibly powerful. Caveats was something that we pulled up. I love the Strata conference, but or however. They don't give you enough time. Those sorts of things are amazingly wonderful indicators on how to build a better product and what customer needs are going unfulfilled. Loves, hates, wants, wishes. We did comparisons, people who preferred, better than, worse than, switched from or to, those sorts of things. We can do much more than sentiment, and so you should be pushing your vendors on it and asking for more than just that. Hopefully we gave you a sense of how kind of flexible and nuanced and context-specific this is. But if you built a sentiment engine 10 years ago, it would not work today. And anything that you that you built now, if it's not flexible, it's not going to work even 5 years from now. Language changes, the emoticons change, the context changes over time, and then also within context. If you code something as motherfucker is always bad, it's going to be wrong, because if I put badass in front of motherfucker and put an A at the end, that's a totally different sense, and you will have missed that if you didn't architect for flexibility. Yes, I did say that. It's an educational conference. So this really starts to get where it gets really exciting. Thank you to the Googles and the Twitters of the world that are starting to append more metadata to the actual content. Thank you for giving us geodata. Thank you for giving us, that might be my hook, for demographic data, whether someone is a male or a female and where they live and those sorts of things. Because now with that set of metadata as one of the features that we are scoring on and that you can do sentiment detection, now if we go back to our example of Nikes are the Tom Jones of shoes. Who's saying that? Is that like a little grandma in Peoria, Illinois, who actually loves Tom Jones? Or is this a urban youth in the Bronx? That actually might be the key right there to give us a totally different understanding of sentiment. So it really is starting to be more expansive in how we build the algorithms, be more expansive in how we think about connecting these dots, and really kind of letting the computer do what it does best, which is to figure this stuff out for us and stop thinking so rules-based. Hopefully computers get to the place where we let them do what they do best so that we can do what we do best, and that's really figuring out the so what. I think we spend far too much time trying to process and filter and work with the data. Technology can be doing a lot more, and so that's kind of how I wanted to sum things up. Thank you very much.